we'll repeat count of 500, and we'll change the size of the packet to 1000. So we can see that once we set this ping to repeat 500 times and we set the size to 1000, we see that we are getting a pattern now when we ping that looks to be the same. So we're seeing, and then we'll be able to see this in the output when I do a show policy map interface serial 00. We see that we have a success rate of 97%. It looks like 487 out of 500 packets went through. So we see that 13 of these packets were indeed dropped. So if we do a show policy map interface serial 00, we should see under the exceeded packets, we should see 13 packets that were dropped if our policy map is indeed working correctly. So once I do a show policy map interface serial 00, we see the exceeded packets was indeed 13. We saw that we had 13,052 bytes that were exceeded our policy, which was to police the committed information rate of 50% the bandwidth on the interface. So we can see that we have limited traffic, and once traffic exceeded the 50% rate, we started to see that packets were indeed being dropped. So that's one example between R1 and R2 to where we set up traffic policing. Let's go ahead and set up traffic policing between R1 and R3. So this time we will set it up, we will configure an access control list. So we'll do IP access list extended 100, and then under this ACL 100 we're going to permit IP. Again, we're going to permit the host. The source is going to be 11.11.11.11, and then to any destination. So if we do a show IP interface brief on R1, we see that loopback 1 has an IP address of 11.11.11.11. So again, this ACL is permitting all IP traffic from the source, which is host 11.11.11.11, to any destination. So what we're going to do in this example is we're going to police traffic from R1 to R3. We're going to police it. Let's go ahead and do this. We'll go ahead first. We'll do that. We did a police on between R1 and R2. We policed the traffic to the CIR of 50%. Again, the exceed action was to drop.